record. All right, that's recording. Sorry for the slow start, everyone. I was in the incorrect meeting ID and it blocked it for everyone else. So I believe today, let's see, where's the? We have one item on the agenda, which is the Mesh Dynamics demo. So thanks for Venki and Rahul for being here for that. Are there any other topics that folks would like to add to the agenda? Give that a few minutes or a few seconds. If there's any other things that people want to add, you can either voice them or just feel free to go into the document and add them there. I will stop my sharing and let Venki or Rahul share their start sharing their demo.
All right.
Sounds good.
Thanks, Sean.
Thank you, Sean. Let me start sharing my screen, and then for the demo, my laptop is not set up properly today, so I'll let Rahul do the demo. But let me start sharing the screen with a few slides to set the context. Can you enable sharing, screen sharing?
Oh, is it not enabled for you? Hold on.
No, this is the new, I think, the new security feature, one of the new security features.
Let's see, advanced sharing options. Who can share? All participants. Okay. Try again.
Yes, working. Alrighty. So I hope you guys can see my screen.
Yes.
Yes.
Okay, cool. Sounds good. So let me quickly set up the problem context a little bit here. We all know that microservices adoption is pretty rapidly growing across all companies. While the operational aspects of microservices are being addressed pretty well, the adoption has actually created new problems for developers. So one of the two areas that we are actively looking at is, as a developer changes a service, let's say in their entire microservices application, how can that developer test her change quickly, including the service interactions and so on? So there's a lot of friction in that process. That's one area. And the second area is around API test, integration test creation. And what used to be sort of unit tests in the monolith world have become some sort of integration tests at the component level, at the service level, and even at the app level. So that requires a lot of engineering effort as well, right? So both of these problems that we are actively addressing, but today for today's demo, we'll actually focus on the developer phase, the testing and debugging of a change in one service as a developer is actually developing it, right, a service. So if you look at the current options that we have, as we talk to a bunch of developers working on these microservices applications, there are three options that we are seeing. Primarily, the predominant one is using dev clusters, right? So if I make a change to one service, I actually push that service to a dev cluster along with other services that I depend on, or the entire application itself into a dev cluster, either in a personal namespace or a team namespace, and start debugging in that cluster. But the problem here is I cannot really use my IDE anymore. I have to rely on debugs and printfs and so on to actually start debugging it. And the other outcome here is also that the cost of provisioning these dev cluster environments for a larger team starts increasing, both from the intro perspective as well as the operational perspective, because these dev clusters tend to be unstable because the services are still under development and people cannot rely on these dev clusters easily for debugging. So they're always often blocked on testing their changes before they even commit code. There are a couple of other options which we'll skip for this particular discussion. We can come back if there are questions. What we are proposing is actually leveraging Istio capabilities to easily record API requests and responses. So Envoy comes by default as a sidecar proxy in all the services. So we can put in an Envoy filter to record the API requests and responses. to each of the services, between the services, at the gateway, and so on. And if we record this API requests from your continuous integration pipelines or staging environments, wherever you let Mesh Dynamics filters listen, these Envoy filters, and we capture them in our Mesh Dynamics services. So as a developer, if I'm changing this catalog service, I can just bring that service up in my IDE and handpick a few requests from the Mesh Dynamics, the desktop version of the product, and drive those requests against my IDE, right? And as the catalog service, when it depends on search or recommender and other services, these requests, outgoing requests, are automatically redirected by the proxy in this on the desktop in our Mesh Dynamics product to the Mesh Dynamics simulation services, if you will, the mock services. And these mocks are actually auto-created from the traffic that we captured from the continuous integration pipelines. That way, the catalog service thinks the search and recommender service are live, but they're actually faithfully being mocked based on the traffic that we saw, right? So the developer doesn't need to worry whether search and recommender are alive. They're for their purpose, they're all alive and kicking. But they're able to use their IDE to test service integrations, component testing, all of those things, right in their IDE, without having to push their change to a dev cluster or relying on a namespace and so on. So that's the capability that we enable. And if they need to change any of the ingress API signatures or responses, or the egress API requests and responses, we enable the developer to edit in place and get that kind of a behavior also of testing going on when the other service is not ready yet, right? So that in a nutshell is what we offer. And we are heavily leveraging this Istio capabilities to deploy these Envoy filters and create those filters, right? If you look at it, there's a one-time setup where we actually create, we have a template which uses a whole bunch of, let me see if it opens up. Yeah, so this is our template Lua filter. It has a bunch of environment, there's variable name, service name, namespace, and so on. And someone can, so there's a filter generator. Once we take the services.yaml from Istio, we just substitute the service names, creates the Lua filters. And whenever you want to record the traffic, you just kubectl apply the Lua filters.yaml. And the recording is going on, right, basically. And you can stop whenever you want by deleting those filters. So that is the way we are leveraging the Istio capabilities to actually set up the recording and enabling developers to test their service changes locally. So let me stop sharing and hand it off to Rahul. Meanwhile, I'm happy to take any questions.
Yep. All right. So can you see my screen now?
Yep.
Okay. So for the demo, we'll just make a couple of changes to, okay. First, let me show you what our demo app looks like. So once again, this is an app built on Istio. We have a few services. We use Istio and Envoy to capture all of the traffic across all of these services when we interact with it. And we use tracing to know exactly the propagation of each of those requests across the services. So when we record the data, we are actually recording traces, not just individual requests. So for example, right now, I have a version of this service running locally within my IDE. And let's say I'm going to make some changes to this service. So how can I go ahead and do that using the tool without any dependency on having a dev cluster available somewhere? So as Venki mentioned, what we do is we are leveraging Istio and the Lua filter to capture data from your CI pipelines or other places where you might be producing reliable data. So here I have one source open here. So what I can do is, since I'm working on this API, I can just take a couple of examples for this and say, okay, I'm going to use those as my examples for the next few requests for my development. And I have the service here running in my Eclipse. So what I'm going to do is I'm going to send this request against the copy running in Eclipse. And also with our configuration, we are automatically mocking all of the egress requests. So here we show you the trace. So movie info is the service I'm going to run against. Here are the egress requests. that are typically associated with it when we captured the data from the CI pipeline. So we are automatically mocking all of these requests, all of these egress requests for this particular request that we are sending. And let's say this is the use case here is a refactoring use case. So we don't expect any significant changes. We more or less expect the same egress request and the behavior to be the same. So let me send that request against the copy running in my IDE. So I'll just say run here. So you can see this is executing here in my Eclipse. And it finished. So here I can now see, okay, how does this look? Given it's a refactor use case, we expect that here is the response. Here's the order. The left-hand side is the original response we had recorded. The right-hand side is the new response. So as you can see, it's more or less similar, but there is clearly the problem. There's this actor's first name array that has been added. So I can now go ahead and modify my code and fix that if I need to do. There's the order of the names that's different in this one particular array. Let's ignore that. Let's say that does not matter for us. So you can use this way to kind of do the refactor case, make the changes, run the request until all of the differences that you care about are gone. Now let's say the next use case is you're actually going to make a change to this service. And oh, the other thing I want to point out is here you can see when I ran this request, once again, we captured the full traces so we can show you exactly what happened with the egress requests. So you can see as a result of the refactor, the order in which these requests are being made has changed. But the result is still the same. And also, but if you want to say, for example, I want to compare two of these requests, since these are mock requests, I only really care about the egress request, I can do the compare. And let's compare the requests. So if I look at the query parameters for the egress request, you can see there's really no change. So it's all good. And obviously the response here, once again, we are doing a diff here. The response, obviously, because it's coming from the mock, the response will be consistent given that the request is fine. Okay, so that's kind of the refactor kind of use case. Now let's say I'm actually going to make a change to this service that also requires a change to one of these egress requests. And let's say that service is not ready, right? In a conventional approach, you will have to either build new mocks for it or you have to wait for that service to be updated. What we can do is we can simply go in here. Let me just go back to the request format. Let's say that the change that I'm requiring requires a new country field in the response from this details request. What I can do is I can just edit the request right here. Oops. And say country, whatever, Canada. Okay, and that's the contract that I have decided with this service. So I'm just going to update it right here. And now with this updated mock, I'm just going to save this to a personal collection. So let me save this thing to a personal collection. Save it. And now I'm going to actually use this new version that I have just created for my use with this updated mock. All right. So that's the one that I have. So if you look at this detail service, I have edited the mock. The mock now has this new field that I added. So the first thing I can do is I can just run that same request against this to make sure everything's good. So I will go back here, so run the request. Request is running. Okay, it's back. So if I now look at the result, you can see, okay, so two things I want to point out. The code that we have changed here, what that we are going to change is going to make a change to this book info when it's done. But as you can see, the book info is everything's fine. But here we put in the new mock, the updated mock. You can see that the mock response has now, the mock responses has changed for the details request. So the country field is there now in the request. Now I'm going to make the actual change here to the service that's running in my IDE. I'm going to rebuild it with the change. Okay, it's done. So I'm now going to send this against the modified version of the code. Okay, it's done. So now if I look at it, you can see we have done something with this new information. We have our changed code is now in adding this country field into the book info that was not there here. So essentially what we have done is we have leveraged the Istio capability to collect a lot of data And we are enabling the developers to make all these changes, edit the mocks, use all of the data to have this handy mocks for all the external services, edit the mocks locally based on whatever contract changes they are planning, and then just develop everything locally to edit those updated mocks until the new services are available. So that's kind of the developer side of the tool that we are building. Questions, comments, thoughts? Is it useful? Does it look useful?
I have a question, Rahul.
Yeah.
As a developer who's using this,
Yep.
What kind of permissions on the cluster or the mesh that's underlying, not the workload under test. Obviously, I get that's local, but the other workloads. What permissions do I need to use this?
So just for the okay, go ahead, Vicky, go ahead.
Yeah.
So there's a data capture side. Yep.
No, go ahead.
No, Vicky, go ahead.
So the data capture side is deploying the Lua filter. So you just do whoever has the permission to apply the filters on the Envoy for the kubectl apply the filters. That is the only permission that we need. Other than that, we don't need anything else.
Okay.
And basically, what we are seeing our customers do is when they deploy in their CI pipelines, whenever they're bringing up these Istio clusters, or if they're with namespace, they just apply this, add this kubectl apply line, and then the traffic, the API requests and responses start getting recorded in the mesh dynamic services, and their developers can then use it for service testing.
So do the deployments, do they tend to enable this Lua filter and then just leave it on in production, and then they can just tap into it whenever they need to?
Not in production, but typically in a staging environment or a continuous integration pipeline.
Okay.
When they do that. In some rare cases, they do it in production, but we have the ability to sample a fraction of the traffic or turn. Then they say a time windows they can apply and delete the filters and so on if they really want to do it in production.
Thank you. I got it.
Yeah.
So some of the data that flows in this traffic is likely to be sensitive in nature. How is confidentiality handled? Are these being uploaded to like a cloud storage bucket, or where does the data go?
So there are kind of two parts to that answer. One is, since we are, you're absolutely right. If we are going to capture this data from production, there'll be a lot of sensitivity issues. But because we are focusing on the CI pipelines or your staging cluster, typically the data is not so sensitive. But even within that, what we are finding is some companies, actually a lot of companies, have policies that even data from their CI pipeline cannot leave the premises. For those, we have to have an on-prem deployment of the backend as well, and the data is stored locally. But there are also a bunch of people who don't care about their CI data leaving, and for those, they are coming to our cloud. If it's production data, yeah, there's not a chance of that data ever leaving the customer premise.
And we have hooks for obfuscating. So based on the paths, like the JSON paths, either request or response parameters, we have the hooks for obfuscating and encrypting those fields. So obfuscation is one way, basically. Is an SSN is obfuscated, and even no one, not even the developers, can see what the actual original value is, right? So if it's encrypted, then there's an option to decrypt it again when we are replaying right at the test, just before testing. So those options are there, but yeah. So the typical one is a cloud environment if it's only they don't care, or the private SaaS. So.
Any other questions? Just love to hear a general response. Does this look like this is something that can help speed up development by allowing developers to do all these things locally and not have to rely on dev clusters all the time?
I think so.
Seems good to me.
Yeah. Go ahead, Sean, couldn't hear you.
I said it does seem useful to me when when I was developing. Right now, I'm working
Public
on
infrastructure. Yeah,
developing Istio, so it
yeah,
doesn't.
that's different.
It's not quite the right question, but
No,
when I
no,
was
no.
developing
Yeah,
distributed applications, absolutely.
yeah, yeah.
Yeah. So yeah, in that context, if you know of developers that can potentially try this out, we are happy for any pointers and intros and so on. So
Well, if there's anybody on the call who wants to engage with them, anybody can
Yes.
feel free to speak up.
Yeah, please reach out to us if you.
I have a
And
personal opinion about development locally. I think there's some extent that developers can work locally, but as the number of resources in the clusters increase, there's a increasing need to go remotely, and especially because when you talk about in cloud environments, especially where Istio is in contest. Uh, Getting development remotely has been more pervasive as locally. So I assume that we're going to start working more remotely. And of course, some of us, especially who work a long time in development, are going to struggle. Say, I want to have things locally as I used to, but the whole technology is moving to more remotely, and that's just my personal opinion.
And just
So they're actually,
just one quick question. Is the primary bottleneck that you see for local development, is it the availability of the data, or that if you're running the containers with the services, your laptop's going to slow down to a crawl as soon as you have 4 or 5 services running? What's the driving reason to need the remote environment?
So it depends on the context, right? It depends on the resources that rely on. So sometimes you rely on a database, sometimes you rely on a third-party system or an API that you have to connect to. And you cannot bring every single resources or every single database locally. So in those particular situations, you have to go remotely. You don't have any other option.
Yep.
you can let those databases be remote. It doesn't have to be local. So that's okay. Right? Some of the data resources can be remote. But then if you're anyway, so the assumption is one service will not require all of the data. It may be a small database, at least from a testing perspective. So that can be local or remote. And you can also mock actually the external service calls like Twilio or Auth0, whatever you have, you can actually mock those calls too.
And that is actually a use case we are seeing quite a bit, where they reach out to an external service and they want to mock that service for various reasons, whether it's cost reasons or other reasons. They want to really mock that external service that they have no control over.
Yeah, absolutely. I think mocking is one strategy. You can apply it. But just bear in mind, like every single time you mock it and then you go to deployment and go into production and then something fails, you have to go mocking again. So I could argue like mocking also takes some time out to your development.
Absolutely. So if you're doing
again,
the
I think,
if you're doing hand generated mocks, you're absolutely right.
Absolutely.
But here, these are automatically created from your CI or staging environment and so on. So that way, these are always up to date and change as your APIs and code evolve.
Yep.
So that's the big advantage that we bring to the table.
Yeah, and that's the reason we are leveraging Istio. It makes it so easier to capture all that data and mock it. Any other approach, it's a pain.
so I think there are multiple ways to tackle this, and certainly this is as good a way, as good an approach as any. It has advantages and disadvantages, obviously, and it's similar to like if you look back to what happened with SOAP, when SOAP was introduced and you had ESBs and the like, that a lot of the tooling there did very similar things with HTTP requests that would mock it out there. And this is similar to that. And then you had tools that came along like Archillion that managed to run unit tests within various environments, including Kubernetes, so you could run against live services. So within our environment, within Istio and microservices, there are a number of options as well. So that you have the approach that you have documented here, the demo tier, should I say. There's also some stuff that we work on ourselves and we've demoed in the community, which tries to address some of the shortfalls that you called out in the initial deck. It's leveraging a couple of technologies, one by Solo.io and another one, so that's Squash, and another one called Telepresence. And they both take different approaches to how you can actually debug live services. So Squash allows you to attach remote debugging sessions to a service that is running in the cloud somewhere, in a Kubernetes environment somewhere. So you're actually debugging something live there. And Telepresence allows you to proxy requests down to a local running service. So like you're doing here, you can run your service locally, but you're actually getting live traffic from the cloud redirected into your service. Yeah. So there are a number of different ways that are possible for debugging microservices within the cloud, and each of them has their advantages and disadvantages. And this is certainly another option which will be of great use to some use cases, some test environments, and perhaps not. But I think all three of these approaches together work really well together.
Thank you. That makes sense.
That makes sense. Yeah.
One thing I really like at solution of you guys is we don't see much solution for developers around Istio. Most of the technologies is around infrastructure. Yep. People talk a lot about networking, which is some of developers not really familiar with the whole networking backgrounds. And when you bring that an easy way, that's really a must. So good work in there.
Thank you.
Thank you. Yeah.
Cool.
All right.
Well,
thank you everybody for your time and the feedback.
Yeah.
Thank you for you guys for demo.
Yeah, for anybody who might be watching the video in the future, I will refer you to the Istio community meeting working doc, which has their emails. Great. So the only other thing that somebody added to the agenda were thoughts on the Microsoft's Open Service Mesh, which launched yesterday. I'm that seems like an undirected question just to anybody who wants to say anything. I will certainly say that it seems like, it's depending on Envoy, so it's picking up a lot of the things that this community has developed over time. Obviously being new, it's not as battle hardened as all the stuff we've done together. I certainly feel like it's kind of validation that the service mesh space is very interesting to a lot of folks. I still see little. I personally wasn't able to see a use case why this would be a great solution for customers as opposed to Istio, but of course I'm biased. I'm very familiar with Istio, and it's thousands, tens of thousands of users. I don't know if other people have thoughts or things that they saw that were interesting. I can't imagine that for Istio users, this is going to be something, very useful. And for new users, unless they're trying a new thing, I don't know why they would necessarily go with Open Service Mesh as opposed to Istio, which is much more, is the leader. But I don't know if other folks had thoughts.
I personally like to see more competition in that particular space, and that really drives more innovation around the whole community. And that also gives developers options to explore new paths into the service mesh.
Yeah, I think you're right. That's why I haven't gotten a time to look through Open Service Mesh in detail yet, but So I don't know if there's any particular new novel innovations in there, but certainly, I mean, they learned a lot from Istio, obviously, and what they did. We might learn something from what they did. Did you see anything that you thought was particularly notable to call out in it?
No, I haven't got a chance to see, like, go into
All
detail
right.
yet. It's way too new for me.
Same thing. Same thing. I mean, it does seem to have, the only thing I got a chance to look at is that there's a handful of, it looks like there's, 2 or 3 main contributors from Microsoft to the project, and they seem to have done the bulk of it. And then there's a long tail of about, like, I think I counted like 7 total developers, and the tail had contributed like 1 or 2 commits. So it seems like it's got, a small little core team at Microsoft.
I think that's certainly true. I think the initial push was done largely by people on the Azure side from Microsoft, from what I can gather.
Well, if I will certainly say that if any of the community members see things there that they particularly like and say, hey, that was really well done, calling that out is a great thing. Does anybody else have other thoughts or concerns about the project? All right. Well, I think we're at the tail of the agenda items. I definitely want to thank the Mesh Dynamics folks for that great demo. I kind of wish I was in the market for something like that right now, because it'd be great to have it.
Well, thank you so much, Sean. And thanks everybody for your time.
Yeah. Thank you.
Yeah. All right.
Nice demo, folks.
Thanks, everyone. I'm gonna shut down the meeting now. Thanks.
Bye.
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 Thanks, bye.